All right, hi there. I'm so glad that you decided to watch this video. I'm going to help you through your weekly review 5, which is quadratic transformations. It's something that we studied last year, but you may not remember how to do. So here's what the weekly review looks like, and I'm going to take you through more than half of them together and show you what you can use on the computer to help you through the rest. The first thing that you need to know are some of the rules about transformation. So here are the basic rules of translations of quadratic functions. If you recall from last year, if you look at the function and you add or subtract inside the parentheses before it's squared, like you notice in the left, and I'll point it out here, right here, that's going to shift the function left or right. And here's the other version. So if that h value inside is greater than 0, then it's going to go to the right. If that h value inside is less than 0, then it's going to go to the left. So if you notice, there's a picture. In red would be the parent function, and in blue would be a transformation of that parent function. So when it's f of x minus 2, it shifted 2 units to the right. Over here, when it is f of x plus 2, then it shifted 2 units to the left. It also can move up and down. That's when you add or subtract to the outside of the parent function. If you add, you move up on the y-axis, and if you subtract, then you move down on the y-axis. So x squared plus 2, it shifted the parent function up 2 units. X squared minus 2, it shifted it down 2 units. Here's some other rules for transformations of functions. So remember, in this video, you can always pause it here, you can rewind, you can come back and look at it. So it shows when you add outside, it goes up, add, subtract outside, it moves the function down. Add or subtract inside the function, then it shifts it left or right. Remember here, if you multiply by a negative, it flips it over the x-axis. And notice in here, this isn't one we talked about too much, but if you multiply by a negative inside the function, it reflects it over the y-axis. And then some of the other ones were the stretches and the shrinks. So if you multiply the function by something outside, if that something you're multiplying is bigger than 1, then it's going to be a vertical stretch. It's going to make it look skinnier. And if you multiply it by a number between 0 and 1, like 1/2, a fractional number, it's going to make a vertical shrink. It's going to make it look wider. If you multiply by a scale factor inside the parentheses, it's kind of in the opposite. It's a horizontal shrink and a horizontal stretch. So when we come back to our weekly review, the very first one in the top, that's your parent function. So that's going to be your basic function as a reference point, y equals x squared. The first one I want to do with you is right here, y equals 5 minus x squared. And what I did is I showed you a picture of what it would look like on the graphing calculator. In blue is the parent function, and in red is the transformation function. Notice, because that x squared has a negative in front of it, negative people frown, so it flipped it upside down. And the 5 on the outside moved the vertex up 5 units on the y-axis. So what we would do is go over to our choices, and we would find the one that matches that, that's flipped over and is moved up 5 units. But notice the width, the steepness, the slope of the parabola has not changed. So that was going to stay the same as the parent function. So it might look like it could be one of these two choices, because they both are flipped upside down and they both go through 5 on the y-axis, but it's actually going to be this top one, y equals 5 minus x squared, because that's the one that has the same width. It didn't change. The one below it got a little bit wider. The next one I want to do with you is y equals 0.5x squared. Here is a picture of what it would look like on your graphing calculator. Remember, in blue is the parent function, y equals x squared. In red is the transformation. You'll notice that it got wider. That's because it had a horizontal stretch. It made it look wider because we were multiplying it by a scale factor of 0.5 inside the parentheses. Notice that the vertex did not shift left or right or up or down, and so that's going to bring us to this one right here. Our next one, y equals -2 times x plus 5 squared. In blue on the calculator screen is the parent function, and in red is the transformation. Three different things happened here. The first thing that occurred is that it flipped over because it was being reflected over the x-axis because it is being multiplied by a negative number. That number that it's being multiplied by is 2, which is going to make a vertical stretch. It's going to make it appear thinner. So it's going to appear skinnier. And then you have a plus 5 inside the parentheses, which means the vertex is going to shift 5 units to the left. So when we look at the ones that we have as choices, the one right here, right next to it, would be the match. Y equals -2 times x plus 5 squared. It's hard to write on here, but I think you get the gist. All right, and then the last two, I'm going to look at them together. Y equals 0.5 times x plus 5 squared, and y equals 0.5 times -x plus 5 squared. I want to look at them together because you kind of need to see the one to understand the other. In blue, again, is the parent function. In red is the first one, 0.5 times x plus 5 squared. Notice that it shifted 5 units to the left because we're adding 5 inside the parentheses, and it got wider. It had that horizontal stretch, that vertical shrink. So it got wider. So when we look for that one, it would be, let's see, there it is. It is in the top right corner. Y equals 0.5 times x plus 5 squared. Now, y equals 0.5 times -x plus 5 squared is a reflection over the y-axis, and that's not one we talk about very much, so that's the reason I wanted to do this one with you. So it did get wider, and it did shift over 5 units to the right. So we're going to find that. You're actually going to find it in two different places. They're both the same, so I'm going to go with this one right here. Y equals 0.5 times -x plus 5 squared. I'm going to put it there. The one over here we'll use again for when we find that a second time around. All right, so then I said I was going to show you how to do some of the other ones. That only leaves you 1, 2, 3, 4 left to do on your own. If you go to this website right here, desmos.com/calculator, you can use that to help you if you want to do this on a graphing calculator, or you can go and rewind this video and look at the rules of functions to help you as well. To model how to use the graphing calculator to do this, I'm going to go into box 1, and nope, well, I was going to try to type it, but I guess it's not going to let me. But I believe the link will work for you. If not, just go into your regular computer, type in that link, and you can type in the functions if you don't have access to one of the graphing calculators in the classroom. Good luck.